Okay, hi everyone, welcome to my channel Fabulous D32 Password. Today we are going to continue from where we stopped, log reading. We are still in log reading. Today we'll be seeing the laws of log reading. Laws of log reading. We are going to look at the first law. It doesn't have a sequence, so I can just call that the first law. The first law, law 1, is what I call the products law. So what does the product law say? It says if we have something in this form, logarithm to base a, the base of the logarithm is what? A, and we have m times m, that this is the same thing as logarithm of a of m plus log base a of what? M. Okay, let me try to, we are not proving this logarithm, so I'm going to state or tell you how this works. So the first thing you need to watch out here is that, if you notice here, m is times what? N. So anytime I have a logarithm number that we are trying to multiply, the laws of the logarithm is saying that we can also solve this as the sum of the individual logarithms. So I will then take this to be logarithm of base a of m plus log base a of what? N. So another logarithm, another law we can also look at is the quotient law 2. We can call this the quotient law. What is quotient in mathematics? This is simply what? Division. Still the same thing here. We are saying that if I have something like log base a of m over n, meaning that the logarithm number here is m being divided by what? N. We are saying that it's the same thing as logarithm of base a of m minus logarithm of base a of what? N. Very interesting. And remember that this is what? Equation. What does equation mean? That whatever you see on the left hand side is exactly the same thing with what you see on the left hand side. Meaning that if, for instance, I have a long question like this, all the what I need to look out for is if the operation here is plus, the first thing that will come to my mind that this could be a possible product law. I will then that first of all, but before I make that conclusion, I will need to look at the base of the logarithms. If the base of the logarithms are the same, and the coefficient of each of the logarithms are what? 1, I can then now conclude that this is what? A product rule. That means I can now use the left hand side. The same thing here. We still have another interesting law under logarithm again. Let's call it law 3, which is what? The power law. What is power in mathematics? It means that it is going to have a base and there will be a number on top of it. And this one comes in 2 parts. So I can consider case 1 of this power law. Case 1 is when the log number have a power. Now we are talking about when the log number has what? A power. For instance, we are saying that if I have something like log base a, the base of the logarithm is what? A, and I'm now having m raised to the power of n. Look at this. The log number itself, the logarithm of the number that we are looking for is what? M. But this time around, it has what? A power. And we are saying that this is exactly the same thing as n log base a of what? N. That is for case 1. We are going to also see case 2. Case 2. Case 2 is when the base is not having the power. When the base is having the power. Meaning that this time around, it's no longer the logarithm question that has the power, rather it's what? The base. We are saying that it's the same thing like this. Assuming that we are having log base a raised to the power of what? N. the base of the logarithm is what? A, but this time around it comes with the power n. We are saying that it is descending, okay, of n. Let's say that this is the base is having the power. We are saying that this is descending as 1 over n of what? Log base A of what? N. These are the very interesting parts. Maybe I will put one last one again. Let's say log 4, which says logarithm of, let's say, log 4, logarithm of a number, to its own base. That means the logarithm number and the base are having the same number. And this is a very simple law that says that logarithm of a number to its own base is always 1. So look at what we are saying. Okay, if I have log base A of A, if you look at this, the logarithm number itself is what? A, and the base of the logarithm is also what? A. The law is saying that this is equals to what? 1. Always equals to what? 1. So these are the very few laws that we are going to consider here, and I think this will be enough to take any question on the logarithm equation. So we are going to try out our knowledge so far with questions. So we are going to practice one or few questions. If you look by my right, we see we have about 4 questions. Let's see whether these laws are sufficient to answer such questions. Okay, we are going to start with question 1.
Start.
Okay, look at the question here. It says simplify 1 over 2 log instead of 25 over 4. Now, in mathematics, when they say simplify, you need to be very careful. What it means that there is going to be one answer to this very question. You don't stop at any place. You make sure that your solution will be the simplest form of that very question. Okay, let's take this question. If you look at this question, we have 2 operations here. We have minus and we have what? Plus. So the first thing I want to do is to use a bracket to show my area of concentration at the moment. So I want to first of all solve these 2 parts. Now if you look at these 2 parts, I would not be suspecting a possible quotient rule. Remember what the quotient rule says. If you look at the quotient rule, where we have our quotient rule initially, it says that if I have log base A of n minus log base A of n, that this is a quotient rule. That means it can be the same thing on the left hand side. Now, if you look at this very question, this is subtraction. It's suggesting a possible quotient rule, but I have to check other factors before I will now use the quotient rule. What are the factors? I will look at the base of the logarithm. Are the base of the logarithm the same? Yes. Base 10, base 10. What problem do I have here? The logarithm here has a coefficient which is what? 1 over 2. And in the laws of the logarithm, it states that this coefficient must be what? 1. So the first thing I need to do is what? To look for a way that I can remove this coefficient, which is what? 1 over 2. Look at what I'm saying. This is 1 over 2 log base 10 of 25 over 4. The problem why I can't use the quotient rule at the moment is because of this coefficient of what? 1 over 2. I will now ask myself, how can I remove this coefficient here? What will come to my mind, I can use the power law to remove this. Let us look at the power law again. The power law says if I have a coefficient multiplying a logarithm like this, that I can also write it in this form. A coefficient multiplying a logarithm, I can also write it in this form. What it means that if I have 1 over 2 log base 10 of what? 25 over 4, 1 over 2 is like n in this case. So what it means that I can also write this as log base 10 of what? 25 over 4, all raised to the power of what? 1 over 2. Are you see this? So we all know in mathematics that any number raised to the power of 1 over 2 simply calls for the square root of that number. So I can also write that this is the same thing as log base 10 of square root of what? 25 over what? 4. Which is the same thing as log square root of 25 will give us what? 5 While the square root of 4 will give us what? 2. Now, if you look at this, we have actually dealt with this part. And it's now having a coefficient 1. So we look at the second part that says 2 log base 10 of what? 4 over 5. How do I remove this coefficient? Because that's the problem that we are having with this line. So how do I go on to remove this coefficient? I will still use the power law again. What does the power law state? That if I have a coefficient times a logarithm like this, that I can turn it to what? Be a power. So this would now be log base 10 of what? 4 over 5, all raised to the power of what? 2. Remember that this is equation. It means that if I have something like this, I can also write this as this. And from here, I can break this down to be log base 10 of what? 16 over what? 25. 4 raised to the power 2 is what? 16. 5 raised to the power 2 is what? 25. I can now come back to this line again. So in this line, instead of me writing 1 over 2 log base 10 of this, I can now write what? Log base 10 of what? 5 over 2 minus log base 10 of what? 16 over what? 25 plus log base 10 of what? 320 over what? 125. So if you look at this, what is the operation here says what? Minus. The base of the logarithms are what? The same. The coefficient of the logarithms are what? 1. Meaning that I can go on to apply the quotient rule. What does the quotient rule say? It says if I have something like this, I can now write this as log base 10. I will write the first number, which is what? 5 over 2 divided by this number here, which is what? 16 over what? 25. Don't forget this other part, log base 10 of what? 320 over what? 125. Now, if you look at this, I'm now using the traditional division instead of what? The slash. Okay? I would like to say that this log base 10 of what? 5 over 2. We said in mathematics that we can change division to what? Multiplication. But if you are going to do this, we are going to take the inverse or the reciprocal of the divisor. So what it means is that if I change this to times, I'm going to take the inverse of the division, meaning that the denominator becomes the numerator, while the numerator becomes what? The denominator. So this will now be 25 over what? 16. Okay? 25 over what? 16 plus log base 10 of what? 320 over what? 125. Now we'll start multiplying. This is going to be log base 10. 5 times 25 will give us what? 125 over 16 times 2 will give us what? 32 plus log base 10 of what? 320 over what? 125. What have I done? I've actually simplified this from being a 3-term logarithm to what? A 2-term logarithm. That's one step. Okay, if you look at this, what is now joining these two logarithms again is what? Plus. And if you remember from the laws of the logarithm, we said that if the operation is plus, what it means that it could be a possible product law. But before we conclude that this is a product law, we are going to check other factors, which is we are going to look at the base of the logarithm. Are they the same? Yes, this is base 10, base 10. What's the coefficient of the logarithm? 1, 1. So what it means that we can also consider this as product law, or meaning that the product law can apply here. So if we are going to apply the product law says that this should not be log base 10 of this very number 125 over 32. Since we are adding, we are going to what? Times. That's the product. Over what? 320 over 125. Are you seeing this? So we start dividing. This 125, 125. What do you mean that? 125 can cancel 125 to give you 1. 125 go here, 1. Can 32 go into 320? How many 32 can we get from 320? We said that it's going to give us 10. So this can be reduced as what? Log base 10 of what? 10. Very good. Now, what is log base 10 of 10? Remember that the last part of the logarithm that says logarithm to its own base. So if you look at this is log base 10 of what? 10. And we say that this is always 1. Therefore, what we are solving, everything that we said here is simply equals to what? 1. What are we saying? That 1 over 2 log base 10 of what? 25 over 4 minus 2 log base 10 of 4 over 5 plus log base 10 of 320 over 125 is equals to what? 1. Okay, it's now equals to what? 1. Thank you for watching. And please remember to, and don't forget to subscribe to my channel, like, and also what? Share. Thank you.